So for Unit 6, we're all going to start off at the same place, and we're going to start with these two definitions for domain and range. So the domain is the more important one. It's the one that comes up more often, right? But range is its kind of counterpart, so we're going to learn them at the same time. So the domain of a function is all of the inputs for the function. So if we have this, whatever function we have, everything we're putting into the function is our domain. And if you remember from before, inputs are our x values, and the range is its counterpart. So if domain is all the input, the range is all of the outputs. And again, if inputs is x, then outputs is y. All right, so domain and range are these kind of two sets of things. All right, domain, all the things I'm putting into my function. Range, all the things I'm getting out of my function. All right, so we've learned a bunch of different ways. We're going to talk about functions. There's tables and graphs and expressions. All right, this is another way of just a bunch of ordered pairs. And from before, when we learned about graphing and its relation to functions, we saw that every ordered pair is x comma y. But in relation to a function, it's the input first and the output second. So this is basically saying for this function, we input 2 and we get out 3. If we input 5, we get out 6, and so on. All right, so from this, I can figure out the domain. I'm just going to use capital D for domain. And a domain is a collection of things. It's known as a set. All right, to represent that we're talking about a collection of things, we're going to use these curly brackets. All right, just like you can see kind of typed out above. So the curly brackets represent a collection of different things. And I'm just going to list off all the x values. So we have 2. Our next x value is 5, 7, and 4. And if you wanted to, you could rearrange them so they're in numerical order, but just listing off everything in this collection of things makes up the domain. And the range, its counterpart, is just the same thing, but we're just going to look at the y values, which are all the second coordinates. So that's 3, 6, 10, and 2. All right, so for these ones where you're given ordered pairs, it's as simple as looking at the first coordinate for all the x values, which is the domain, the second coordinate for all the y values, which is the range. All right, so I think you should be able to do this one on your own. All right, do the same thing, domain and range of this function g. And you should get something like this. All right, so all of our x values, -2, 0, 5, and 10 are our domain. Our range, all the y values, 2, 4, 8, and 12. So now the more important thing with domain and range, I think that's going to come up a few times throughout the semester, is looking at a graph and using that to determine the domain and range. All right, so we could use like a computer to generate a graph for us and then use that to figure out the domain and range. All right, so in this example, and this one we're looking for domain, so we're only interested in the x values, the input. All right, so for every single point on my graph, just like we kind of did with that last example, we're thinking about what is the x value. So if I'm at this point down here, the x value, I just kind of connect it to the x-axis, and that x value is -5. And I would technically do this with every single point, but you don't have to do it for every single one. You just get a basic idea. For all these different points along my graph, I'm getting these x values into the final one there. And from those, I can figure out that my domain, again, it's a set of things, so I'm going to use the curly brackets. But the easiest way to write this, because it's a collection of all these x values, it's like this infinite number of x values, is to say it starts at -5, and my x values are bigger than that, and it ends at 8. So it's the set of all the x values between -5 and 8. All right, just one small thing to note, because it might come up, is that in this example, we have these open circles at the end. All right, these open circles tell me that I should have these inequalities like this. If I were to change these open circles to closed circles, then I would add the equal sign underneath my inequality. It's just a small thing between the less than and less than or equal to. That might come up in the other examples. But this one, we're looking at the x values that this graph hits, and it's from -5 to 8. All right, exact same graph as last time, but now we're looking at the range. And remember, range is y values. So we do the same thing, but now we're worried about the y values we're hitting. So from every single point, I'm going to go towards the y-axis. Again, you don't actually have to do it for every single point, but you're getting an idea of what's happening. So for all these points, I'm looking at where they're going to hit the y-axis. And I can see at the end, my range is going to start down there at -11. and we're talking about y values in this case, and it's going to stop up there all the way at the top at positive 11. All right, so that's my range. All the y values between negative 11 and 11 get hit by this function, so that's my range. All right, we'll do one more example before you do one on your own. So find the domain of this function. Again, domain, think about x values, so I would start and look at all these points and see that all the x values I'm hitting, my domain, those are going to be from negative 4 to positive 4. And you can see right here I have this closed circle, so I put the little equal sign underneath of the inequality. All right, but domain, all the x values that your graph is hitting. Same thing with range. The most common mistake people make with range is they look at the first point and find that y value, which is here, and look at the last point and find that y value, and they use that to figure out their range. But you can have these curves and stuff that hits everything, so make sure you're thinking about the entire function. So when I think about the entire function and all these y values that I'm gonna hit, I'll see that my range, the lowest down value I get is 0, and the highest up value I get is 2. All right, so make sure you think about the entire function and not just the very first point and the very last point. All right, but now you should be able to do this one on your own. Go ahead and find the domain and range of this function. And you should get that your domain is everything from negative 4 to 7. Those are the x values I'm hitting. And my range is negative 11 up to 5. Those are all the y values I'm hitting. All right, now for this learning objective, we're going to try the kind of new thing we're going to do for the first few units of this semester. So we'll still do skill checks for certain learning objectives. For other learning objectives, we'll do these practice problems on Delta Math. All right, so for this learning objective, we're going to go to Delta Math. You should have already signed up, and there's a link on the Google Doc to get there. But you're going to go to Delta Math, sign in, and you look for the assignment that's 6.11, because that's this learning objective. So you're going to do the 6.11 assignment. All right, and then you should just have kind of one type of problem you have to do, all right, finding the domain and range. I bet with these problems on Delta Math, it allows you to do problems outside of class and still make progress. It also allows you to kind of see solutions as you're working if you get a question wrong. But of course, if you're working on these problems and you run into a problem, you keep getting them wrong, you're not figuring out kind of what's going on. All right, make sure you let me know and don't just guess a bunch of times until you get it right, because this is kind of replacing the skill check, so I want to make sure you know how to do these things before you move on. All right, but once you get done with the problems on Delta Math, you can just go on to the next learning objective. There's no skill check to do for this one, but there will be for the next learning objective.